So what we're going to only cover is the strong acids, okay? And strong bases, sorry. Because kind of like in Talladega Nights where he says, if you're not first, you're last, kind of like that, we're going to use that same logic. If it's not strong, it's weak, all right? So the strong list is a lot shorter than the weak list. So we're going to learn the strong one so that when you are looking at these different formulas, you're kind of saying, okay, that one is on the list, so that means it's strong. If it's not on the list, it's going to be weak. So we're going to start with bases. I think it's the easiest one. So strong bases, just go ahead and label in this little corner. You don't need a lot of room, I promise. Strong bases, okay? So for strong bases, it's all going to be based around drawing a B on your periodic table. Okay, so strong bases down here in the left corner, you're going to draw a little B on your periodic table. Okay, and that B is going to be starting with lithium. So this is in group 1 on your periodic table. Lithium, and then sodium, potassium, rubidium, cesium. Okay, if you were not able to fit all those letters in, you can just put lithium and cesium and put a line in between them just to say that everybody in between those on group 1. So I'm kind of following on the periodic table. You have this little part, lithium down to cesium, okay? All right, so that's group 1. Group 2, we're going to go across, we're going to have barium, strontium, and end at calcium, and that's as far up as we go. So we're making a B on our periodic table. Anytime we have one of these metals attached to an OH, okay, that is a strong base. That means there are only 8 strong bases. Once again, if it is not strong, then it is weak. So you have to be able to look at a list of these things and say, is it strong or weak? That's kind of the homework this weekend, okay? All right, so strong bases, you want to look to see, is it lithium hydroxide, sodium hydroxide, potassium hydroxide, rubidium hydroxide? You get the point? Okay. So if you do need to write down a couple of those examples so that you understand kind of what you're looking at, I'm going to draw mine above because I have more room up there. So I'm just going to give myself a couple examples to look at for when I go to study. Sodium hydroxide, that is a strong base. You could have something like strontium hydroxide. That is a strong base. Notice you brought the 2 down and across, and that's because strontium is in group 2 with that +2 charge. Okay, strontium's here, so that's where that's coming from. All right, so those are your strong bases. You have 8 of them. Any questions so far? So that one's kind of not too bad. All right. We wrote this example yesterday, so moment of truth. Copper 2 hydroxide, is that one strong or weak? Remember, if you're not strong, you are weak.
Strong. No.
We're kind of all split, huh? Okay, is copper on the B that you just drew on your paper? No, so therefore it is weak, okay? So this is a weak base, okay? So just kind of give yourself that little reminder. If I were to give you something like cesium hydroxide, CSOH, what was that one? That one is a strong base. Good. Okay? All right, so that's all we're going to write about bases. We're going to leave that one alone. Okay? All right. So now let's go ahead and run through our strong acids. Okay? So I'm going to kind of use this little space that was right here on your paper. You don't need a lot of room, although I wrote right into that space. That's okay. I'm just going to write strong acids. Okay, so strong acids. All right, so strong acids. The things that make these strong, just to keep in mind, okay, I'm going to show you a quick picture. So if you don't mind, look up there, okay? This isn't on your page. What I have here is I have hydrochloric acid and I have hydrofluoric acid. Both chlorine and fluorine are part of group 17, right? So they're literally right next to each other on the periodic table. They're right underneath each other, all right? But this one is considered a strong acid, and this one is considered a weak acid. So just to kind of give you the background as to why this one is strong and this one is weak, it has to do with the things that I circled on this image. What I circled on the image were these things called hydronium. They're H3Os. So really what's going on here, if you really just focus in on this, these look the same, right? It's a little gray bubble with an open bubble. When I put those into water, right, these are all little water molecules, what's going to happen is up here, those H's are going to get transferred to a water molecule, right? And down here, same thing. But as you can see, this happens 10 out of 10 times. This one only happened 2 out of the 10 times. So this one ionizes or dissolves, dissociates, whatever fancy word you want to use. This one does it 100%, whereas your weak acids are only going to do it 20%, right? Something like that. So it's the whole idea of something completely dissociating. That's where the strong idea is going to come from, okay? The same thing happens with these strong bases. They completely ionize to make these OHs, okay? That's where it's coming from. All right. Now, go back to getting our list done. So we had 2 categories. We had binary acids, the things with 2 elements. So this list is very short. There are only 3 binary strong acids. That is, it comes from this little sentence. I bring, make sure that's a capital B, clay, capital C. I, Br, and Cl. So that means hydroiodic, hydrobromic, and hydrochloric acid. Those are your 3 strong binary acids. Hydroiodic, hydrobromic, hydrochloric. So that's a little review on all of your binary ones. Have to start with that prefix of hydro. All right. For our, or actually, are you guys okay? We're good? Okay. So for our oxy acids, okay, for oxy acids, there's a good number of it. I've never memorized the number of them because I just don't feel like it, because I've memorized 1 rule for my life, and that's kind of it. So the rule is for this, because I think it's easier to remember 1 rule than it is to remember a bunch of names, okay? So 1 rule for oxy acids. So I have to write mine down here. I apologize. All right, for oxy acids, you are going to ask yourselves, does it have 2 or more, underline that statement right there, 2 or more, so 2 or equal to or greater than, right? 2 or more oxygens than hydrogens. So you're going to ask yourself that question for every oxy acid. Does it have 2 or more oxygens than hydrogens? Okay? You're going to look at the little subscripts. So, if it does have 2 or more oxygens than hydrogens, if the answer is yes, then that means it's strong. Okay? If the answer is yes, then that means it's strong. If it's no, then it's weak, right? All right, that's it. Just 1 rule. All right. So, let's go ahead and see how we do. Let's look at 1 through 12. Okay, we're just going to kind of run through it as quick as possible. I'm going to go slow for the first 3 or 4, and then the rest of it we're going to flow through. Okay, so this is your practice for this. Okay, so number one was binary. So we're trying to decide, is this one strong or weak? So looking over here, binary, you have to think, are we part of I bring clay? I bring clay, right? Is this one part of I bring clay? HBr. Yes, so that means it's strong. Okay, because of the BR. All right, the next one we have sulfuric acid. Sulfuric acid. This one is a oxy acid. So we're going to look at that. We're going to ask ourselves, does it have 2 or more oxygens than hydrogens? So we're going to look at the subscripts, 4 and 2. So we're going to do a little math in our head. 4 minus 2, what does that equal? equals 2. Is that 2 or more? Yeah, absolutely. It's 2. All right, so this means it's strong. Okay? So oxyacids, you're asking yourselves that question. You're doing a little math with the subscripts. All right, next one we have carbonic acid. Okay, for carbonic acid, we have 3 and we have a 2. So we have 3 minus 2. What does that equal? 1. Is that 2 or more? No, so it's weak. All right, next one, hydrosulfuric. We circled that one. That means it's binary. So binary is if it has iodine, bromine, or chlorine. Is this one iodine, bromine, or chlorine? No, so that means it's weak. All right, the next one, chlorous acid. We're asking ourselves 2 or more. So we have 2 minus 1, which is 1. So is this one strong or weak? This one is weak. Okay, I'm going to write it right here because I can't fit any more on that side. All right, so weak. All right, how about hydronitric acid? This is binary, so we're back to the ivory clay. It has nitrogen in it. Is that iodine or bromine? Yeah, this is weak. Perfect. All right, sulfurous acid. Sulfurous acid. So we have 3 minus 2. That is 1. So is that one weak or strong? Weak. Okay. Down here, acetic acid. We have 2 minus 1. What does that mean that one is? That one is also weak. Good. And then we have 3 minus 1. That means 2. So that's strong. How about hydrofluoric acid? Is that part of ivory and clay? No, so this one is weak. Next one we have sulfurous again. So 3 minus 2, that told us that that was 1. So that one is weak. And then finally, chromic acid, we have 4 minus 1. I'm sorry, 4 minus 2. 4 minus 2, which is 2, so that one is strong. All right, so you can already see from this little list that there is not as many weaks as there are strong, or not as many strongs as there are weaks. So get these rules memorized. The back of this page is for homework. I want you to label all of these as acid or base. I'm not asking for all the naming, but you need to recognize the acid and the base. So you're looking for hydroxide, and then I want you to answer whether it is strong or weak. So kind of continuing. You already did the naming on your practice today on Schoology. Okay? All right, so acid or base, strong or weak. Make sure you get that done. Hold on. What did you say? 5? Oh, 5 is a weak base. This is a weak base. It is ammonia. It doesn't follow any of our rules. It's one that you have to memorize. You guys have a great 3-day weekend. Have a good weekend.